Hey everyone, welcome back to my workbench and my Logitech camera not being very productive today. Oh, there it goes. All right. So, this is a early morning, not too early, but it's a morning video, which I usually don't do. So, hair's a little messed up. This wearing a t-shirt and some pajama bottoms right now, so nothing too exciting here. But I'm working on the 5200 analog controllers, and I have myriad to build. Uh, so I have a silly number of keypads, and then I have last night, 2 nights ago, no, yesterday, I printed up lots and lots and lots of components. And then I have printed up 16 of these. These are the joysticks that go over the giant pile of industrial joysticks. So, what I did this, a lot of people are wondering what the centering mechanism is, because the traditional 5200, the centering was more or less a joke. It was just a piece of the rubber boot itself doing that work. So how this works is this is an industrial joystick here, and there's actually there's a whole, I'll take one of these apart one of these days, but there's a whole mechanism here with a set of extension springs, and that's what actually does the center. You can see the rubber boot actually is literally only there for dust ingress. The joystick itself is a self-centering. It snaps back really fast, actually. So what I end up doing is like take off the these are, it's just I don't even care which one I order because I rip it off anyway. This is a, oh, it doesn't say. It's either 5K or 10K, not that it matters. But this gets pried off, and I install a little coupler here to, I size this to mate up with the surface that's on here. That mates up with this, and then this has an interference fit with the knurled potentiometers go in there. And because of the thickness of the housing and this guy here, and where the potentiometer ends up, one of the potentiometers kind of sits, if you look at it from underneath, it sits like this. And this one potentiometer, this pot ends up being on this back of this keypad. And what you have to do is actually space out the, you just feed this through here, and it spaces it out. I've done all this dimensioning before, so this is actually the exact height of that. So basically you're compensating for the height of the keypad sticking out. So that gets you where you need to be. But I also discovered I had to get longer screws, because the screws that come with the joysticks don't actually fit, won't make good enough contact. So all I'm doing this morning, I'm doing a real mass production run right now, so I want to complete a lot of these at one time. I used to be a manufacturing engineer, so I know the whole concept of the theory of constraints and all that fun stuff, and how you mass manufacture it. So I got a little spacer in there. This goes through, and I got to CNC a bunch of enclosures. They're down in my basement. I keep my CNC in my 3D printer down in the basement, but it takes 22 minutes for it to cut a top enclosure. So yeah, then I got these all printed out. I printed out a batch of 16 of them at once. So they all turned out like identically, which is nice. And this just fits over that. I don't want to shove it on there right now because it's actually kind of a tight fit. I usually have to sand this just a tiny bit and then made them together for life. They don't come apart. And giving away all my secrets here, but yeah, this is a little coupler, and this gets really tight. You don't even need to glue it. It's a really tight interference fit, so this basically is going to be on there forever, which I don't want to do because I have to put the bracket on first. Oh, there it goes. Tight fit. And I made these cute little brackets here, so when these get mounted in on this little bracket, and then it comes with washers and nuts, so I put the washer and nut on there. I set this to around 82K and have that mated together. And actually, I could put I still have to put the nut and washer in there, but this gets mated up to the joystick. And then you have a little bit of, it's nice, you have a little bit of, what I do at the end is I calibrate it. You could tweak this a little bit so you get a good amount of adjustment. So I hook it up to my 5200 and make sure it's precisely centered for both, and then off you go. And then these are little spacers for the 3 buttons on top. I actually found a nice module for that, which is I got a big box of garbage down there. This is a little 3-button module. What's nice is the ground is common for all of these, and how the Atari 5200 works was column 4. You have column 1, 2, and 3 on the keypad, but column 4 is actually sits kind of like this. Even though it's up here like this, actually it's up here like that. But you have 3 rows, and this is column 4. So you hook up the column 4 to here, and this one actually has a weird common VCC, which I just cut off these little resistors on top here, and it makes it really easy to use. So that's the little module I have. It's all nicely printed, and this little guy is the spacer here. And this little spacer, I do a short screw in the top, short screw in the bottom, so everything's screwed together, which is nice. There's very little glue. The only glue I have is for coupling this guy to the potentiometer, and I do a little glue for the bracket, but other than that, it's all screws. This is screwed on too, so it should be pretty darn durable. And I did the interference fit on that little coupling, so it doesn't you don't have to worry about glue failing there. In the spirit of mass rolling, at this point I have like absurd amounts of parts right now. That's the button for it. Piles of Neo Geo extension cables, which is what I use for it, and these are great because these are replacement cables for Neo Geo. Used the 15-pin DB, use the DB15 as well, same pitch, and it's nice because it has a string leaf built into it. So I just notch my case and lock it together, and so when the case screws together, I have this nice built-in string relief. So that was nice. And then I went through and created. This is a harness board, so I know cut lengths for all my different wiring inside here. This is very crude because I actually do have real diagrams for it. So that's the actual diagram, but the this is actually from the DXF file I use on for my CNC to actually cut all the holes in here. It reminds me I need to cut 2 more holes for this next batch. I had to hand drill 2 holes, but now I know where they go. I'll just have the CNC cut those holes instead. So, but yeah, that's what happens. You have to go into mass production or something. I never expected to sell I think I sold 15 of these in like a week, and I haven't posted anything to any forums or anything because I need to catch up on all of this. Before I say, hey, I have some back in stock, because I literally have to build. I have 2 partially assembled, which are going to go to 1 customer. Then the rest are all getting batched together. So if you ever need to make a bunch of anything, what you do is you do the same boring task over and over and over again. And actually, the switching of tools are what... Oh, I got my controller cables. Excellent. The I saw a pop-up of my mail there. The key is don't switch tools. So when you work on something, use the same tool over and over again. You don't switch tools. So switching tools is what slows you down. So like in this case, all I'm doing is splaying out this cable. Then I'll strip all these cables. Then I'll solder just these 3 conductors. And I'll do the same thing for the next one, where I'll split the 4 conductors and then solder all of them. So what you do is you don't switch tasks. You just keep doing the same mundane task over and over again. And you'll get done much faster. And I remember it was an interesting thing. It was about the theory of constraints. So you can only move as fast as your slowest process. So if you wonder, okay, how long did it take to, say, build a car? And the answer is it takes about 12 minutes to build a car. It's like, how the hell do you build a car in 12 minutes? Well, 12 minutes is the slowest process on the line. The slowest process would be the, say, like the paint booth when they paint the car. That's something you can't really speed up. So as long as what you do is, if you have a constraint, is you shorten up. See, I'm not even following my own rules here. I'm stripping cable. I should just say splitting cables. That's all right. I'll just keep this in my hand and keep stripping cables. So how it works is you go down on each individual operation, you time it, you figure out which is the slowest operation. Sometimes, but what happens if you do that, you try to break the constraint, you try to speed it up. So the easiest way to do is just do 2 of the same. You have 2, say, your paint operations, your slowest operation. So you can do is you have 2, 3, 4, 5 paint robots running at the same time. And that way your actual paint time gets really low. And then you figure out what your next constraint is and you try to fix that. So it's all pretty interesting stuff how you can see, I'm keeping the same tool in my hand and how quick it's going. So then I'll have, get a little worn there. My problem is it's just me. So I am the constraint. So for this, the slowest process is actually the final calibration of the controller, because that's something I actually have to hook it up when it's more or less completed and do a final like check of the centering. And I usually play a couple of test games just to make sure it's working in game while playing a game. And that's actually the slowest part of this. Even then, that's only about probably 5-6 minutes. So theoretically, if there was a bunch of me, I could crank these out. I can crank out 6 an hour, but I don't think that's going to work. So, I mean, this is slightly artisanal, I would say. But, no, I know not to waste time on, like, switching tools and stuff like that.